Good day. This is Bennett, also known as Jeremiah. Today I'm going to talk about dynamic equilibrium in solutions. This is very essential for past papers. If you want the playlist of chemical equilibrium, the playlist is found at the top right of the screen. So, let's begin. Alright, let me use this particular equation from Mind the Gap in order to give you the full package to apply in the past papers. So, we're given a particular equation. Whenever the reverse reaction is favored, the solution mixture is blue. Whenever the forward reaction is favored, the solution is pink, right? And then delta H less than 0 means that the forward reaction is exothermic, right? So if delta H is less than 0, or if they say delta H is equals to maybe minus 1.2, right? It's still the same as them saying delta H is less than 0. So you are given this particular equation. So number one, you have to understand an addition of an acid like HCl. So whenever an acid is added, what does it do? An acid increases the concentration of H plus. So if in this equation you've got H plus, so let's just say there is H plus, because notice there is no H plus here that we're seeing, right? But let's just say there is H plus. So if there is H plus, maybe 2H plus, some people might be confused of the fact that they're seeing H here, and then they're seeing H here, and then they're seeing H here. Which one must they choose? You have to choose the one that says H plus only, right? So let's say it has H plus here. So when you add an acid increases the concentration of H plus. So adding an acid is the same as increasing this. So what happens when this is increased? You will tell them that the system will oppose the increase in H by favoring the reaction that uses it as a reactant. So notice whenever this thing is increased, so whenever this is increased, the fourth reaction uses this as reactants, right? Because notice in the fourth reaction, these are reactants and then these are products, right? But in the reversed reaction, these are now reactants and these are products. So if H plus is increased, the system will oppose the increase in H plus by favoring the reaction that will use it as a reactant. Then you'll tell them that therefore the forward reaction will be favored and the reaction mixture will turn pink. Literally, so you have to understand that the forward reaction will be favored because in the forward reaction, this is the reactant. So it's going to favor it so that it can decrease this, right? It opposes the increase in this. So that's how it is. So if HCl is added, it increases the concentration of H plus, right? But if there is no H plus, if there is OH instead, you have to know that it's like opposite. So it increases the concentration of H plus, but it decreases the concentration of OH. So if there is OH anywhere, if there is OH, I'm talking about literally OH alone, right? So if there is OH, it will decrease the concentration of OH. So what happens when this is decreased? So if this is decreased, you tell them that the system will, or you will tell them that according to Chatelie's principle, the system will oppose the decrease in OH by favoring the reaction that uses it as a product. So notice if the reverse reaction is favored, this becomes the product. So notice when this is decreased, it's going to oppose the decrease such that this will now increase, right? It's going to try and increase it. So it's going to favor the reaction that uses it as a product so that it can increase, right? I hope you get it. So if this was instead increased, it will favor the reaction that uses it as a reactant so that this can decrease. But now that it is increased, rather now that it is decreased, it's going to favor the reaction that uses it as a product so that it can go up again, right? So that's how it is. So you have to know that when an acid is added, then it increases H plus ions. If there is no H plus but there is OH, it decreases OH, right? So now let's go for another one. So let's just say instead of adding an acid, I add a base. Okay, so this one is still the same. I'm just going to rush through this one. Let me just explain something. So if a base is added, the base now decreases H plus ions, right? So it decreases H plus ions, but it increases OH ions. So it's just the opposite of acids. So literally, so I don't need to spend time here. Okay, let's go forward.
Just before I continue, if you want to be tutored, whether it is online or physically, whether it is the situation where you're struggling in maths or whether it is the situation where you're good in maths but want perfection, take a screenshot or save these details. Whether you're studying Cambridge, which is the UK curriculum, or whether you're studying NSC, which is the South African curriculum, or IEB, or native courses which start from N1 to N6, or any curriculum you're doing no matter which country you're at, we offer tutorials. We've got lessons and practice sessions 5 days a week. We also give you tests once a week so that we can check your improvement.
Watch the video that is found at the end of this video in order to know the prices and the updated contact details just in case this was have changed. Alright, let's proceed. Alright, what if they're telling you they're adding water? So if they're adding water, water can split right into H and OH. So water increases H plus and it also increases OH. Alright, apart from the splitting, if there is no H or OH, this is another thing you must do. Alright, so another thing you must do is that you must check, is H2O part of the equation, right? So how do you know which one to focus on? Notice there are two of them. There is this one and there is the other one, right? So the one that you focus on is the one that is pure H2O, right? Not the one that is combined with cobalt. If they add H2O, so if they add H2O, they're just increasing H2O, right? So that's how it is. So what you'll tell them is that the system, you'll tell them according to Le Chatelie's principle, the system will oppose the increase in H2O by favoring the reaction that uses it as a reactant. So the fourth reaction will be favored, right? So the fourth reaction will be favored so that this can be used as a reactant so that it can decrease. So you tell them that the fourth reaction will be favored and the solution mixture turns pink. Literally, when it comes to the colors, you have to mention it. There is marks for it. Alright, so now let's talk about hydrochloric acid. So there is something else I want to show you. So whenever you have an acid, you have to check its compounds. So we know that acids increase H plus and decrease OH, right? So apart from that, you have to check, for instance, if it is sulfuric acid, H2SO4, notice that it has HO4, but HCl has chlorine. So if it has chlorine, it means that if there is chlorine, right? Notice that this chlorine, you have to look for a pure one, right? Not this particular one. So if there is chlorine, it means that if you add HCl, you are increasing chlorine. So if you're increasing chlorine, you say the system will oppose the increase of chlorine by favoring the reaction that uses it as a reactant. So the reverse reaction will be favored. Then you'll tell them that therefore the reaction mixture turns blue. So the reaction is favored so that this can be used as a product, right? So that this can decrease. So that is how it is. So if it was sulfuric acid, dilute sulfuric acid. So sulfuric acid, you have to be careful. There is dilute, right? And there is concentrated. So there is dilute. Okay, so and there is concentrated. Forgive my handwriting. So concentrated. So let me just not write it in full. So if it is dilute, then it functions normally as the other acid, right? It increases H plus, it decreases OH, right? And then apart from that, you have to check what it contains. Notice that it has SO4. So if there is SO4 here, it will increase the concentration of SO4, right? So the thing is, what about if it's concentrated? If it is concentrated, sulfuric acid is a dehydrating agent. So if it is concentrated, then we are removing H2O. Concentrated sulfuric acid always removes water, right? So if it is dilute, you treat it as a normal acid, right? It increases H plus, decreases OH, and it increases SO4 if we see SO4, right? But now, if it is concentrated, you have to know that we're just decreasing water. So, in other words, we're decreasing this. So you tell them that the system will oppose, you tell them rather that according to Le Chatelier's principle, the system will oppose the decrease in H2O by favoring the reaction that uses it as a product, right? So that's what you will tell them. Then you say, therefore, the solution mixture turns blue. Alright, what if I add a solution that has got, or if I add rather something that has got Cl, like NaCl? Whenever you add something that has Cl, you are just increasing Cl, right? Or apart from checking Cl, so that's why, for instance, when we added hydrochloric acid, Cl increases, right? So if it contains Cl, it means we're increasing Cl. But apart from that, if it contains the other compound, like if Na was part of this equation, we're also increasing Na, right? So now, apart from that, you have to be careful of something. If we have NaCl or any other thing that is Cl, it will split, right? Now, if there is Ag, this is what is not taken note of. If there is Ag, you have to be careful. If there is pure Ag, not Ag combined with something, but if there is pure Ag, whenever we add something that is chlorine, we are actually decreasing Ag, right? So you have to take note of that. Why are we decreasing Ag? It's because, remember, this will split. And when it splits, this is actually going to bond with Ag to form AgCl. So Ag will no more be pure, right? So whenever we add something that is chlorine, we are indirectly decreasing Ag. Alright, let's talk about another one. What if I add a catalyst? What does a catalyst do? A catalyst neither favors the forward or reverse reaction, right? Even in the graphs, you'll realize that a catalyst just favors both of them in a way. It increases the rate of both the forward and the reverse reaction. So the solution mixture will just become purple pink. Even in the graphs, if you just see that everything, exactly everything increased, then you know it was a catalyst that was added.
Alright, we have reached the end of this video. I have included a playlist of similar type of questions. If you enjoyed this video, please like the video and subscribe to my channel. Any questions you've got or any video you want me to create, please comment below. See you in the next video.